See, we're in week 4. Hard to believe already. So today you'll get some of the final data entry. It is the final. What's that?
Oh, sorry, I was still on dancing.
Oh.
And Elizabeth.
Oh, what were we thinking? Dr. Tango. She's on our team. But does she think she knows line dancing? We'll have to text her. Something. Okay. Yeah, but I don't want to like dance. Just want.
Oh, you don't want to touch.
No, I don't want to touch anybody. Okay. All right. So this week you should be wrapping up data entry, and we'll be putting in manure test, manure quantities, fertilizers that you use or are planning to use. And then we're hoping, there's a glitch in the system, of course. But we were hoping for you to enter in the nutrients that you're going to be applying to the fields this week. So putting manure on the fields, putting fertilizer on the fields, looking at the soil test recommendations, and then matching that with on-farm inputs, and then adding fertilizer if necessary, and if that's a part of your fertility plan. So that will be the homework this week. And then next week, we will be kind of going through various aspects of the plan, making sure that, things are complete, that your fields are in balance. We can't get started on that till next week because it's not finished in the system, but making sure that you haven't over applied nutrients, and also making sure that you're meeting the regulatory requirements around the P index. And so basically kind of going through and making sure that the plan is meeting the standard. And then hopefully kind of wrapping things up. We have one more week after that, and that's really hopefully to finalize the plan. So next week, again, we'll be mostly kind of going through, making sure the plan meets the requirements, finishing up data entry if you haven't actually been able to do that, and getting to a place where in the last week, hopefully we're just wrapping up everybody's plan, reviewing them, making any final adjustments. So hopefully you've all been doing your homework, and we'll be done in a couple of weeks. All right. So today we're gonna talk about manure and other on-farm nutrient sources and nutrient availability from those, kind of how that's calculated, where that information comes from, and then I'll turn it over to Lindsay to go through Go Crop. All right. So one of the things we talked about early on was really trying to use on-farm nutrient sources first, and then adding purchase fertilizers after that. So understanding how much nitrogen, phosphorus, potassium you're going to get, and micronutrients as well from manure that you have on the farm, plow down or crop residues, legumes, sod, and cover crops is all part of building your plan. Okay. So depending on what type of livestock you have, or maybe you don't have any at all, the amount of nutrients in the manure really is highly dependent on the type of livestock and really what they're eating. So high producing dairy cows being fed high end diets with, ample amount of purchased concentrate normally has quite a bit of nitrogen, phosphorus, potassium, and everything else. Grain, is used to supplement cattle diets, to build rations, to make milk. And a lot of the nutrients in those concentrates basically gets wasted. It's not utilized by the animal, and then it makes its way into the manure. One of the things that we've actually tracked over time is farms that sort of go from feeding high grain diets to feeding no grain. And you can watch the concentration of nutrients in that manure get cut in half when they stop feeding grain. So grain's a big expense on farms. So there's always interest in like feeding less grain, feeding more forage. But, the flip side of that also is that grain ends up producing, high fertility manure. So as long as you're kind of utilizing that manure as a high-end fertilizer source, it can be very valuable. And so it's important to have your own manure test, because what you're feeding your animals, ultimately will influence the nutrient content, and no two manure are alike. So testing the manure is really important. When you buy fertilizer, you don't just ask the fertilizer people to drop off whatever, right? You expect that there's going to be an analysis with it. And, it's the same with manure. It's fertilizer, should be used that way. You should be capitalizing on it. And in order to do that, you have to know what's in it. Every manure source on your farm has to be sampled on a yearly basis. And, you only have to sample it once, but you can see that just sampling that, manure out of a very large manure pit that may hold millions of gallons once a year is also still just kind of a rough estimate of what's in there. Um, and, as an example, if you think about 2023, where we had so much rainfall, the amount of water that was going into manure storages was substantial, and it was diluting the nutrient content of the manure. And if you were still calculating nutrient availability based on, you know, an old manure test, you'd be sorely disappointed, because it was, in some cases, a half of what was normally in the manure, or even a third. So taking that test is important. When you take it, really is kind of up to you. You are only getting one sample a year for the most part. Some people are into it, and they take multiple samples. Today, even there's technology that will calculate in line nutrient content of manure. So as you're actually applying it, there's new systems. I don't know how well they work, that will tell you what the nutrient content is of the manure going through the spreader. I don't think we tried to get one here in Vermont, but it was around the time of COVID, and we never were able to access it. But, there is new technology coming that will hopefully actually make this even more accurate. But having a test is important. We do have book values that you can use. They're in the nutrient recommendations for field crops, which everybody has a copy of. I talked about it in the first class. So you can use the book values, but, having your own test is best. It's also the law. You're supposed to, again, have at least one sample per manure storage each year. If you've been taking manure samples for a really long time and you feel like the levels are fairly consistent most years, you can start to think about making your own book value, right? Where you can average your manure tests together over a period of time and use that value, because sometimes you do have, an off year, or you didn't get a good sample or something. So you can create your own book value. But again, you have to be taking samples for a number of years to be able to do that. Okay, so let's talk about nitrogen, because the things we've kind of already talked about, the phosphorus concentration of the manure and the potassium concentration of the manure are considered 100% available in that given year. So if you apply manure to the field and the manure test says there's 8 pounds of phosphorus in 1,000 gallons, theoretically, all of that 8 pounds is going to be available that year. Okay, same with potassium. So when you're writing your plan, you get credit, all of the credit in 1 year. With nitrogen, as we've talked about, it's more variable. There's lots of different forms of nitrogen, and there's different forms of nitrogen in your manure too. And they're not all available immediately. Some of them have to be mineralized, right? So there's organic nitrogen that has to be broken down, and that takes time. And then you have some ammonium nitrogen. It'll vary based on the type of manure that you have. That is considered 100% available to the crop. But as we talked last time, it's easily lost. So we have to plan or try to predict how much of it we'll actually get. All right. So this is right out of the nutrient recommendations for field crops. And you can see on the top, and if you pull out your manure test as well, you have total manure nitrogen. And then that's broken down into 2 forms, organic nitrogen and then ammonium nitrogen. If you have solid manure or compost, generally the amount of ammonium nitrogen is very small, or there's nothing at all. But in liquid manure, there's generally about 50-50, about 50% of the nitrogen is in the organic form and 50% is in the ammonium nitrogen form, give or take. Okay. And then you add those 2 numbers together, and that's the total amount of manure nitrogen that you have available. All right. Okay.
Hey,
So
Heather.
here's just, yeah.
Quick question. Are there supposed to be slides you think we're seeing? Because we're just seeing you.
Oh, well, that's lame. Sorry. Yes, I think you should be seeing these slides. Oh, I have to share them. Well, that's too bad. Here we go. I forgot to do that. Sorry.
Thank you. Claire's on the ball. She caught you.
Thanks, Claire. There's a monkey. Okay. All right. So that's what I was talking about in the manure. 2 forms, organic, which is slowly available. And then you have the ammonium nitrogen or the urea N, and that is readily available, but easily lost. Okay. And it's roughly about 50-50. But again, that's the point of conducting your own manure analysis, so you know exactly what you have there. Okay.
Okay,
So,
the slides are not in presentation mode if you wish for them to be.
well, I do, but
Okay,
that?
just throwing it out there. We see it.
Well, what do I do, you guys?
It's on that screen. It was showing the whole thing.
Yeah, on ours it shows.
And there's one, the HTML.
I'm just gonna talk.
I mean, we can see the slide. It's just not in the presentation mode. So it's still workable.
Lindsay's working on it. She's got her magic going.
I'm hoping.
She's hoping.
Lindsay, I think there's a checkbox that has use presenter view, and I think you might not want that, so we can see the full. Do you see up in the, go over
Yes.
right there, maybe uncheck that? Is that gonna help?
You guys are good. How does that look for you folks?
That's good, now we
Good.
can see it.
Yep,
Okay.
perfect.
Incredible.
Teamwork.
Doing great,
Teamwork
Lindsay.
makes the dream work. Okay. There's no I in team. My old soccer coach used to say that. Okay. Alrighty. So as we're trying to figure out how much nitrogen will be available to the crops that given year, we have to figure out, well, how much of the organic N will be mineralized, and then how much of the ammonium N, which is 100% available, will we be able to retain? Okay, so with the ammonium nitrogen, we're worried about immediate losses, like we talked about last time, leaching, volatilization. Primarily, we're going to look at volatilization. And then with the organic N, it's really about how much of that organic matter will be mineralized by the microbes in the soil. So we're trying to predict these things. And as we talked last time, they're hard to predict because they're influenced by a lot of factors. So again, it's a rough estimate. Okay, so here is a standard liquid manure test. And you can see there's 12 pounds of ammonium nitrogen and 13 pounds of organic nitrogen, 8 pounds of phosphorus, 20 pounds of potassium, some pounds of magnesium and calcium. So generally adding manure actually over time will increase the pH of the soil because you're adding a lot of bases. It's not like adding lime, of course, but when you think about putting on multiple applications of manure over numerous years, you're getting 10, 20 pounds of calcium and magnesium and potassium, you're putting on a lot of bases. So over time, the pH generally goes up when you're adding manure to the soil. Okay, so if you put on 7,000 gallons of manure per acre, that would give us 175 pounds of nitrogen, 84 pounds of ammonium nitrogen, and 91 pounds of organic nitrogen. Okay. And then we get 56 pounds of phosphorus and 140 pounds of potassium. So you can see putting on, kind of a standard rate of manure gives you a lot of nutrients. Okay. For corn or grass, a general recommendation would be about 120, up to about 200 pounds of nitrogen per year for a corn crop or a high producing hay crop. Usually, our phosphorus recommendations are fairly moderate, I would say. Not always, but usually around 40 pounds of phosphorus. And then potassium, depending largely really on your soil type, can range, as well. There can be a big range, but, let's say generally around 120 pounds. So you can see with a standard rate of manure, you basically can supply way more nutrients than you need for that crop. But the real question is, well, how much of all of that nitrogen is actually going to be available to that crop in that year? Okay, so the ammonium nitrogen itself, as we talked about last class, can volatilize really easily. And so if you want to retain more of the ammonium, you should incorporate it into the soil, because when you surface apply ammonium, remember I said the chance of it volatilizing is really high. It depends on the conditions, but a lot of it will be lost, okay? If you put that ammonium nitrogen into the ground, then it will not be lost to volatilization. Volatilization only happens on the surface, okay? So here you can see, and again, this is in your booklet, manure ammonium loss after days after spreading. So as the number of days after spreading get more, you can see the amount of loss goes up. And like, so a couple weeks after spreading, again, just on the surface, you can see for various types of manure, right? So this is thick, thin, solid. You can lose most of the ammonium nitrogen from just leaving it on the surface. So you had 12 pounds per 84 pounds. It's all gone if it's not incorporated. You don't retain much of it. The risk of loss is really, really high, okay? So you can see availability, right? The opposite of loss. The availability as you go over time goes way down, again, because the chance for loss goes way up. So, 14 days after spreading, depending on the type of manure that you have, you can only have about 20%, maybe up to 60% available. The rest is gone, theoretically, right? This is a prediction. So how do you retain manure, nitrogen, ammonium nitrogen? You till it into the soil or inject it, right? And as we've kind of gone away from trying to till as much, we definitely have more risk of volatilization. Okay, so that's a downside of reduced tillage. All right, so this is the availability of the ammonium nitrogen from liquid manure that's applied to the soil. So not everybody, but many people have liquid manure with different dry matter. So, how thick it is. And if you incorporate it into the soil immediately, you can see that you retain almost 100% of the nitrogen, which is why a lot of people have gone to injecting manure, because you get more nitrogen retained when you do that, okay? Now, as those number of days, again, to incorporation go up, right, the amount of ammonium goes down, right? So you lose a lot more if you wait to incorporate it, okay? And this is in the spring. So this is spring applied manure. So clearly, let's say you're growing corn, you're putting on 7,000 gallons of manure, and you could get up to 84 pounds of nitrogen. Really, theoretically, that can feed in, most corn crops in Vermont. Not all of them, and I can hear Jeff in Rutland going, wait, no, we need more nitrogen. But anyway, you can get 84 pounds if you get it into the ground right away. And that could be incorporating it or injecting it. But you can see on hay ground, a lot of that readily available nitrogen is lost. Okay, so this is one of the reasons why, especially in no-till, we try to encourage injection, because you retain more of your nitrogen, a lot less is lost. Okay, so this is in the fall. So one of the reasons we discourage like fall applied manure is because there's no real place for the nutrients to go, right? If you're applying manure in December, where are those nutrients going to go? And we all understand why you may need to apply in December and not in the following spring, but you lose basically, almost all of the ammonium nitrogen when you apply the manure in the fall. Okay, so it's wasted nutrients. And where do they go? Well, you know, they leach, they volatilize, they get converted into other forms. But, you know, you might get 15% of the ammonium nitrogen, so you're gonna get 12 pounds out of 84. Right, so there is a significant value to waiting to the spring if you can to put those nutrients on, if you want to get the most out of them. Sometimes we're just, you know, trying to get rid of them, I guess. I didn't mean it that way. Just got to disperse them over a broader period of time. Okay, so then the organic nitrogen breaks down more slowly because it's got to be mineralized by soil microbes. And how quickly that happens depends on all kinds of factors. One of the primary factors that we look at is the dry matter of the manure and also the soil drainage and whether or not the manure is tilled or left on the surface. So clearly, if you're putting the manure into the ground in close contact with microbes, right, immediate contact, you're gonna get more breakdown in that first year. Okay, versus leaving it on the surface, it's still going to break down, but you know, somebody's got to move it from the top to the bottom, right? Somebody meaning, you know, a worm, a beetle, other microbes. So it doesn't break down as quickly. If you have poorly drained soil versus well-drained soil, poorly drained soil breaks down slower. Okay, well-drained soil breaks down more quickly. Okay. And again, depending on the dry matter. So 20% dry matter or less. So this would be like liquid manure in a well-drained soil. If the manure is tilled into the ground, you'll get 36% of the organic nitrogen in that first year. We get really into the weeds here, 24, 20%. I mean, in general, most people plan on 30% of the organic nitrogen being available in the first year. Okay, like these are little nuances here, in my opinion, but that's what we do. Now, if you leave it on the surface, you get quite a bit less, because again, it takes more time for it to break down because it's not in as close contact with the microbes, and it's also exposed to, you know, different elements. Okay, so tilled versus surface supply, you get less. And so you're only getting 30 to 20% of that organic N in the first year. So we had 13 pounds. We're going to get 30% of that. Well, what happens to the rest of it? Well, it'll break down eventually. It just takes longer, right? Because some of the nitrogen may be harder for the microbes to get, may be more difficult to break down. So if you think about lush green biomass and microbes going after that versus the gnarly roots, right? You would imagine that the microbes would break down some of that lush material really quickly. And then the more heavy carbon material, like in a root, would just take longer. Okay. So same with manure. They're going to break down the more easy to break down material. And then over time, they'll break down the rest of it. So you actually get credit for your manure that you applied, let's say in 2025, you'll take 30% of that nitrogen credit this year. And then next year, you'll get 12 more percent. And then the following year, you'll get 5 more percent. Okay. So it's the gift that keeps on giving. And when people say building organic matter is like building your savings account of nutrients, that's why. Because all organic matter is a little bit different. And how quickly it breaks down in the soil depends on the quality of it. And it helps to build up nutrients that become available over time. So if you keep adding manure or compost or whatever kind of organic matter you're adding, you kind of keep building that bank up, right? So you're taking credit for 3 years in a row, but then you put something more on and then you keep getting credit over time. Okay, so theoretically, people should be keeping track of this. A lot of people don't, but you should be able to take, some credit for the manure you put on last year and manure you're gonna put on this year. Ready? Okay. So just on the bottom, the example we had was in 7,000 gallons of manure, you get 91 pounds of organic nitrogen. And in the first year, you're gonna get somewhere between 32 and 21 pounds of it out of that 91. So you're not getting all 100 and what was it, 75 pounds. You're getting a very small fraction of that to feed the crop. And you could be sorely disappointed if you looked at your manure tests and just did the simple math, right? And said, oh, 7,000 gallons, 25 pounds. I can feed 2 years of corn crops with this. But the reality is, especially with nitrogen, there's all kinds of loss and transformations, and then it takes time for some of it. And so you need to calculate for that and be realistic somewhat about what you're going to get. And then at the end of the day, it's still just a really good guess. And the reason I say that is because if we get 35 inches of rain, I already told you what can happen to the rest of it, right? It can leach, it can volatilize, it can be denitrified. So we are taking kind of normal conditions and trying to predict how much of that nitrogen will hopefully be there for your crop that season. If it rains a lot, or it's really cold, or it's really hot, all of that could change. And that's why we do encourage, especially in corn crops, for people to take a PSNT, the pre-sidedress nitrate test, which will measure nitrates in real time, and make, again, yet another prediction about if there's enough nitrogen in the soil to grow that crop for the rest of the season. So it's another tool, especially if you're applying manure and other organic amendments, to help you kind of dial in nitrogen needs on the farm. In a dry year, you could have plenty of nitrogen available. In a really wet year, it could all be lost. And it's that different. So using a PSNT is a really helpful tool. All right. Okay, so in our example here, we actually only ended up with 62 pounds of available nitrogen from that 175, and the remaining needs of the crop were another 60. Now, if we went out and took a PSNT right before we top dressed, that should help us dial that in a little bit. Do we actually need that 60 pounds of fertilizer? We might actually need more, but we could also need less. And so that's the value, I think, of running that test. It's a good test. And it gives us just a little more information before we go and spend a bunch of money. Okay, so let's talk about nitrogen credits from legumes. And we don't have a lot of 100% alfalfa stands in Vermont, or legume stands at all. we primarily have mixed, grass legume fields. But this more kind of shows you the value of having 100% alfalfa stand. What kind of nitrogen could you get from that level of legume in the field? And you can see that it's quite substantial, that you can get up to, almost 200 pounds of nitrogen credit per acre with a good alfalfa plowdown. And that's why she's the queen. She produces tons and tons of nitrogen. And again, if you are growing alfalfa, it's funny, most people wait until there's one strand of alfalfa left in the field. And they still call it their alfalfa field. Oh, out in the alfalfa field, there's like 2 random little alfalfas wiggling around out there. But, you're better off to actually terminate the stand when there's quite a bit of alfalfa out there, because you will get a lot more nitrogen credit for the following crop. Now, this is something I want to make the point, because a lot of people do this nowadays. And this is just showing alfalfa, but it holds true for grass as well. If you're terminating a perennial forage stand that has above ground biomass, right, and below ground biomass, you're going to get more nutrients, okay, that return to the soil than if you've harvested off the first cut, which a lot of people do, right? Harvest off the first cut and then go in and no-till corn. Because you've removed all of the kind of quickly degradable biomass nitrogen, and you're going to feed it to your cows, which is fine. Okay. So if you're taking off a first cut of hay, and let's say it's 18% protein, okay, that means it's 3% nitrogen. And if you have 1,000 pounds, right, you have 30 pounds of nitrogen that you just removed from the field, just in the above ground biomass. Usually you have more than that, right? So you'd probably be removing 60 to 90 pounds of nitrogen by harvesting off that first cut. That now your corn crop's not going to get. Okay. So generally we assume that when you rotate from sod to corn, you get 70 to 90 pounds of nitrogen in that first year. That's only assuming that you have above ground biomass, because that's the stuff that degrades quick. Now, if you've removed that and all you have are the gnarly roots that I was talking about, that they're tasty, but they don't break down that quickly, okay, you will not get as much nitrogen credit for that corn crop. Okay, and so that's something you have to plan for in your plan. And if you're not writing a plan, just for you to know that it's not the same at all. Okay. And this just kind of shows that from, the alfalfa perspective, which there's more nitrogen being added to the soil in an alfalfa crop, because remember we learned last week, it's associated with a bacteria that produces nitrogen. Okay, grass doesn't do that. Only legumes do that. So in a legume crop, you have all the embodied nitrogen in the plant biomass, right? And normally as livestock farmers, you look at that as crude protein on a forage test. So you have all of that nitrogen embodied in the plant. Plus, with a legume, you have all the nitrogen that's in those little nodules. So it's just a lot more than in a grass crop, okay? You've made new nitrogen. In the grass crop, you're just taking nitrogen out of the ground and holding it in its plant biomass, and then you terminate it. So it's just kind of going back into the soil. All right. So again, with sod, a standard sod crop, which would be grass, maybe with some clover in it, usually you're getting about 70 pounds of nitrogen available in that first year, sometimes a little more depending on how it's managed, credit for whatever crop is coming next. Okay. And then in the subsequent years, just like with manure, you'll get additional credit because it doesn't all break down at once. Okay. And Go Crop will account for that for you. Now with cover crops, you know, that's a whole different ball of wax in itself. So cover crops are usually grasses here in Vermont, right? We do have some legume cover crops, but most of the cover crops grown are winter rye or winter wheat. They're grass. So the nitrogen that you might be able to take credit for from growing a cover crop is whatever that cover crop scavenged out of the ground and put into its biomass, right? So it's, again, mostly recycling and scavenging and kind of protecting nitrogen that was in the soil, holding it in its plant biomass until you terminate it. So what will influence how much nitrogen is in that cover crop is how much nitrogen was left in the ground when you planted it and when it was growing, how big it gets, right? So if it's only this big, you're not going to get much nitrogen from it. How mature it is when it gets actually terminated the next year. And then how is it terminated, right? So if you're terminating a cover crop that, let's say, is 12 inches tall, very green, very lush, very thick, maybe you even put fall manure on that field, you could potentially be holding 30, maybe 60 pounds of nitrogen per acre in that cover crop. But mostly the cover crops aren't that great around here. I shouldn't always, but you know, sometimes they're really good. But not only are they not always that lush and thick, people try to get rid of them as soon as humanly possible. And so there's not usually a whole lot out there. So taking credit, nitrogen credit for those cover crops is really highly dependent on how you manage those, kind of how good they are in the spring. But I would say on average, if you feel like you're doing a pretty decent job, we have through our research seen about on average 30 pounds of nitrogen being held in that cover crop. And I think it's really kind of up to you as a farmer or as someone working with farmers to decide if you want to take, you know, really take that credit or not. Okay. And so, you know, again, planting date obviously will influence how much biomass is out there. So, you know, if you're planting early, usually you're going to get more biomass. It has more time to grow, more bigger roots, takes up more nitrogen. And then the next spring, when you terminate it, there'll be more available for the crop. So it's just kind of agronomic principles here. This was a project from many, many, many years ago that I did with UMass Amherst, looking at planting date of cover crops. This is rye cover crop, and how much nitrogen was actually kind of accumulated in the biomass. And then that cover crop was turned over into the soil. So it was actually incorporated into the soil. And then we went back out and took PSNTs at the time of top dress. And you can see, you know, depending on the planting date, we had different levels of nitrogen available from that cover crop. But if you have a nitrogen deficient soil and you put a cover crop out there, the cover crop's gonna be nitrogen deficient too. So there's a lot of factors here. I mean, ideally, you'd want to sample it and figure out how much is there and how much nitrogen is in it, but nobody does that. All right. All right. So let's talk a little bit about fertilizer nutrients. Fertilizer nutrients are generally considered 100% available when you put them on the ground. Again, it depends a little bit. Some of the organic fertilizers that people buy, like rock phosphate as an example. I mean, it stands by its name. It's rocks of phosphorus. So they're little rocks and they take time to break down. So, you know, not all fertilizer that you purchase is going to be 100% available. But should be. But we can talk about that, or whoever you're working with can kind of define that a bit more. All right. This is more about fertilizers. I want to leave Lindsay plenty of time. So I just want to, we talked a lot about nitrogen and manure and the nitrogen cycle, and that nitrogen cycle applies to fertilizer nitrogen too. So it's easily lost, especially urea forms of nitrogen, because it can volatilize really quickly, especially when it's soil applied. So just exactly what we were talking about with manure. You can put that fertilizer on the surface of the ground, which a lot of people do, right? They go out and fertilize their grass or they'll fertilize their corn and they'll put urea right on the surface. And just like manure ammonium, it can be lost very quickly. And so the nice thing about manure fertilizers is that you can actually now buy fertilizer with a protectant on it. I mean, you could do it for a long time, but they're called inhibitors. And we'll talk a little bit about those. The other way around losing nitrogen to volatilization is applying different sources of nitrogen. So ammonium sulfate, which tends to be way more expensive, doesn't volatilize very much. So, you know, some farmers do use ammonium sulfate to reduce volatilization issues, but again, it's more expensive. It also acidifies the soil pretty quickly, has that sulfur with it. So you can decrease the pH pretty fast if you're using ammonium sulfate, but it doesn't volatilize as much. All right, so with the inhibitors, what you're trying to do is block some of these pathways where nitrogen is lost. So, you know, we have nitrification inhibitors, which slows down the conversion of ammonium to nitrates. So if you have soils that are highly leachable, you might use a nitrification inhibitor so that it stays in the ammonium form longer, right? Because the nitrate form leaches way more easily and is lost, can be lost very quickly, especially depending on the soil type. It can also be lost to denitrification. So again, some people will use a nitrification inhibitor to keep the nitrogen in the ammonium form. You would generally use a nitrification inhibitor if you're incorporating the nitrogen. This inhibitor doesn't impact volatilization. So you can really use the wrong inhibitor. So you have to kind of know what you're doing here. The other type of inhibitor is a urease inhibitor, and it blocks the urease enzyme, which is required to convert ammonium to ammonium gas. So a urease inhibitor is commonly what's used on a lot of urea fertilizers when they're surface applied, because it will keep them from volatilizing as quickly. I think that these products are pretty necessary in today's climate. They're really like they're all about risk management. And so I do hear from people sometimes, oh, it doesn't work. And actually, if you look at the research, like the literature, you'll see, well, sometimes they work and sometimes they don't. Well, yeah, because it's influenced by the environment around it, the microbes that are in the soil and the conditions. So if you do a 2-year study and the conditions aren't good for volatilization, your product isn't going to look like it works. And I can say this firsthand because we have a 3-year study going, and many years actually, where some years we see it work and some years we don't. But when we see it works, it really works. You know, in those years, which are really conducive for volatilization, it's amazing the results. And now there are urease inhibitors that can go into manure. So we've been doing a bunch of work on that to basically apply the inhibitor into the manure so that it keeps that ammonium from volatilizing. And in years where we have high risk of volatilization, it works really well. But the last 2 years, with it being cloudy and really wet, it hasn't worked well at all. So anyway, okay. We are almost out of time. But I wanted to go through the soil test. I know that people have already entered their soil test information, but I wanted to go through some of the numbers here and then let Lindsay show us Go Crop. So here is a standard soil test that you would get back from UVM. And a lot of people are also using Dairy 1 these days, or Agri 1, which is out of New York. They are a private lab. They do a lot of forage analysis, and they have also gotten into soils and some other analytics as well. It's a very good and reputable lab. The UVM lab outsources their samples, so they actually go to the University of Maine. And the reason for that is the same reason why Cornell doesn't have a soil test lab, right? So it's hard for soil test labs to make a living, and our lab supports the main lab, so that we have one regional lab. And the Cornell soil test lab shut down many years ago and supports the Dairy 1 lab. So those are 2 reputable labs that you can send soil samples to. The key thing for us in Vermont, and is part of the regulation, is that you have to have your soils tested with the modified Morgan extractant. Very specific. And other labs, you know, if you're sending your soils to the Midwest, or even to the South, they don't use the modified Morgan's extract. They have their own extract. And, you know, a lot of that has to do with the types of soils that we have. It's the best extractant to extract nutrients out of the various soils in Vermont, and New England. So Maine uses the modified Morgans, Massachusetts, Rhode Island, New York uses Morgans. That's probably a personality, like, scientist issue where they didn't get along. And anyway, so New York uses Morgans, Vermont and other New England states uses modified Morgans. The law requires you to use modified Morgans. So if you want to use Bray 1, Olson 3, or Morgans, you can. I mean, you can, but you're not meeting the regulatory requirement. And like I said, other labs offer it, but you usually have to request it. So you're better off to stick with UVM or Dairy One. Okay, so on your soil test, you can see you get this nice little graph, which is great. It kind of gives you a sense of if you're in the low, medium, optimum, high, or excessive category for these three macronutrients. Remember, we already talked about nitrogen not being on here for all the reasons we've already discussed. So don't be suspicious. It's just, it's not going to be there because it would be useless to you, useless information. Okay, so you can see here on this soil test, the phosphorus level is medium, the high end of medium. The potassium level is also medium, not at the high end. And magnesium is up in the high or almost excessive range. So what does these categories mean? So they're basically telling you that if you fall in the low range of this nutrient, that the probability of seeing a crop response from adding this nutrient is really high, right? You're almost guaranteed to see a response in your crops if you're in the low range and you add the recommended amount, okay? If you're in the medium range, the probability of seeing a response starts to go down. There's a medium chance that you will see a response if you add what the soil test says you should add, okay? Once you're in the optimum range, essentially adding a nutrient, more nutrient, you're unlikely to see a response in your crops. And if you're in the high or excessive range, why are you adding more of that nutrient? Okay, the probability of seeing a crop response probably doesn't exist. So you're wasting money, time, nutrients. Okay, so that's what these categories mean. So if you're in the low category, that would be a good place to invest some nutrients. You are probably going to see a crop response by doing that. And same in the medium category. When you're in the optimum category, things are pretty good. Really, at this point, you're adding nutrients just to maintain the soil levels, right? Because when you get into low, all of a sudden your recommendation for nutrients becomes hundreds of pounds of nutrients. It's very expensive, really difficult to get all of those nutrients just from manure on the farm. You may not have enough manure to add that much, okay? So you really want to try to keep your soil tests and soil levels in that optimum range so that you're just maintaining them over time. And again, when you get in higher excessive, especially with nutrients like phosphorus, then you start running up against, potential environmental issues. But that's what these categories are telling you, okay? If you go down, you get a lot more information about micronutrients, soil organic matter, other things that we've talked about in class. So you see your pH right at the top, and this is a great pH for growing whatever crop here. Looks like we're growing small grains. So right where we said it should be, in that kind of moderate 6 range. And then you can see the actual values of nutrients that are found when they were extracted out of the soil in parts per million. So 3.9 parts per million of phosphorus, which again was in the medium range, high medium. The optimum range for phosphorus is 4 to 7. So more or less you're in the optimum range, right? Okay, so if you're below that, you're probably going to need to add nutrients. And if you're above that, you're not going to need to add nutrients. Potassium levels are at 85 parts per million. You can see the optimum range is 100 to 130. So we're a little below that. We're probably going to need a little potassium as well. Calcium ranges, magnesium, sulfur. we don't make sulfur recommendations in Vermont, or other micronutrients except for zinc and boron, but we'll kind of get into that more next week. We'll talk about some of the micronutrients and potassium. But if the levels are exceptionally low compared to the average, so these aren't optimum ranges, but just kind of average ranges, you should consider applying micronutrients. And we'll talk about this more next week as well. All right. So here's aluminum. We had talked about aluminum early on, how it's a strong acid. Soils in Vermont, especially up in the hills outside of the Champlain Valley, tend to have really high aluminum. So up in Newport, up where Jeff is, usually those soil tests will have aluminum levels over 100, over 200, okay? If they're really high, they may also have a really low pH. And they may also have a really low phosphorus. Because remember I said the aluminum will bind with the phosphorus and make it unavailable. But on this soil test, it's really low. This is probably, yeah, it's from Grand Isle. So old ocean bottom means that we have lots of calcium. You can see the calcium levels are really high in this soil. And we're generally not worried about liming or dealing with aluminum. The soil organic matter level here is 3.3%. Really, organic matter levels in Vermont should be over 4, unless you're, on a very light textured soil. So if you're on a sandier soil, 2% could be good, but most of, our fields in Vermont should be over 4. The state average is like 4.5. The cation exchange capacity, we talked about that as well, right? That's the ability for your soil to hold on to positively charged nutrients. Usually we like to see this level between 10 and 12%. If it's high, it generally means that there's probably a lot of clay, right? Remember I said clay has a negative charge. If it's really, really low, and the organic matter is low, it's probably a sandy soil. And if you remember, the way to increase the cation exchange capacity on sandy soils is to build the organic matter levels. All right, so down here we have something called base saturation. And this tells us on the cation exchange of the exchange sites on your soil, how many of them have calcium, how many of them have potassium, and how many of them have magnesium. So if you could visualize a circle, right, being a clay particle and all these negative charges on it, 91.9% of those negative charges have calcium on them. 1.6% of those negative charges on your soil have potassium on them, right? It's the ability to hold on to positively charged nutrients. So most of the binding sites have calcium. Some of the sites have potassium, not very many, and some of the sites have magnesium. Okay. Is there anything wrong with this? No, but you want to check this against your potassium parts per million and also your magnesium parts per million. Because if these are deficient, you're going to need to add them. Okay. We know that calcium is the majority here, and it could be keeping your soil from holding on to these other nutrients that it needs. So we know we need to add some potassium here, okay? And the magnesium levels are high, so we don't need to add anything there. But oftentimes, you'll see low magnesium levels and a magnesium recommendation. That should not be ignored. Okay, a lot of people will ignore it when they see it. But if you're feeding cattle especially, you know, you can get into some real issues, metabolic issues with animals, with low mag, high potassium levels. All right. So on the soil test down at the bottom, if you put in to the form, right, that you fill out when you submit your test, what crop you're growing and the yield, then you'll get a recommendation. And this recommendation comes straight out of your booklet, nutrient recommendations for field crops. And once you put your soil test information into GoCrop, the recommendation should auto-populate.
I'll talk about that.
Okay, it's not working.
It's happening.
Okay. If you don't like the recommendation, you can modify it. You can override it. And a lot of times people will adjust, especially the nitrogen level slightly, dependent on their soil or, you know, experience, etc. So, all right, I think that's it. I'm gonna turn it over to Lindsay.
Heather, could you talk for a moment on the importance of calibrating your manure spreader and what that might look like? Because we have to check yes, right? So like what
Oh, yeah.
what
Yes.
counts as calibration?
Okay, yeah, so it is a requirement to calibrate your manure spreaders. And you know, I mean, ideally, you should use a set of scale. If you have a box spreader or solid manure, you should be calibrating by weighing the spreader full, and then going out and actually,
Just look like a little silhouette.
oh,
That's fine.
that's okay. Probably not okay for everybody else. But knowing how much you're putting out in each load is really, really important, right? It's just as important as knowing what nutrients are in the manure. There aren't a lot of people that do a very thorough job of calibrating their spreaders. Now with a liquid spreader, you know, it only holds so much, right? It's only going to hold so many gallons of manure. And so you have a 7,000 gallon manure tank and you're writing your plan and you say, well, I have a 7,000 gallon tank. So every time I put on a load of manure, I get 7,000 gallons. But that's, you know, not, it's not always full for one thing, usually not. So calibrating manure spreaders is it's work. We do have scales at our office. We can definitely help you do that. In your binder, there is a whole fact sheet on how to properly calibrate your spreader. And I'm actually not going to go through it because it involves tarps and given areas and weighing the amount of manure that comes out, and it's great and everybody should do it. In the least, you should know how much a spreader load of manure weighs so that you can have a better sense of what you're putting on the ground. Today, a lot of liquid spreaders have injection units and they're able to actually, you know, calculate exactly what's going on the ground, but still a lot of people aren't using those. So calibration is key. If you want help with that, we're certainly willing to help. And so Lindsay wanted me to talk about this because there is a question that says, are your spreaders calibrated? And it is a requirement to know what's in a load of manure, both the volume, and also nutrient wise. So that's all I'll say about that. And there's a little document in your binder under the manure section. Yep. Oh, and by Winway. He's been gone a long time. He was the best extension person in the state of Vermont. He'll
Until
tell you.
you came along.
Well, no, well, I mean, he died, so. But no, he was very critical of my work. He would call me up and tell me I wasn't on across the fence enough. But he was the extension person, and here's his little from Winway in 1983, anyway, so. You can just use the volume of the spreader for liquid, but with solid manure really should be weighing and looking at the distribution pattern, you know, based on the speed that you're going, etc. But the information's in your binder. Okay, Lindsay, I will let you do the go crop.
Would you mind muting and turning off?
I
I
think
didn't
that's,
mean to, but I did.
we don't have a terrible echo, so I think whatever you've done has been successful. It's achieved our goals.
Do you need it here? You don't need it,
I don't,
because you're on there.
Oh, they can see.
I haven't shared my screen yet. We might still need it connected so that, yes, other folks here can see it. So would you want that? Yeah, I do.
But you want this on.
Yeah. Oh, yeah, we can, sorry, no, we can do it here. Thank you. That was the plan I had an hour ago, which apparently I forgot.
How,
Sorry, we're working on it.
to that Zoom meeting.
I know, I'll just do this.
Okay.
Oh, there is more cord.
It's 25 feet long.
Hey,
Go back to.
Remember Kate saying
Yeah.
that last time?
Yeah, she was
Got
really
25
excited.
feet.
okay, how are we doing here?
Well, Lauren sent me,
Okay,
she was like.
We're
"Oh,
working
we have
on
the
it.
longest
Get in
one."
there.
And I found one that was 10 feet and I was like, oh, this is really long. And then I looked over and there was one that was 25 feet. And I was like, that's the one we're getting. So might be a little obnoxious, but.
okay. We can see it, my screen on our TV, but can folks see Go Crop and their situation?
Yes, I see the sign-in screen for Go Crop.
Can anybody hear me? That's another question I have.
Did you hear me
Getting
reply,
zero
Lindsay?
response from that question.
Oh,
Oh, wait a minute. That's on my end. Okay.
'Cause it doesn't-
Susan, I think you were telling me that everything's working, right? But I couldn't hear you.
almost everything. Yes, I see the sign-in screen.
All right, thank you.
Good.
All right, so here we are in GoCrop. You're gonna go to www.gocrop.com. You're gonna log in. And it's gonna take you to your farm and your plan. But now that we're here, I'm gonna throw a curveball at you. Because I want to show you how to import soil tests. I don't think we got to that last week. And I want to show you what that looks like this week. So I'm going to show you how to get there to GoCrop, and then I'm going to show you how to change any Excel file you have to a CSV and some tips and tricks in that CSV to set you up for success in importing. So once you log in, you can see that we're in V4. We've got your plan here. But before you even click into your plan, we are going to venture back in time, back into classic mode. So please press the orange button here, go to back to classic. And you'll see your farm here. This is the classic version, classic look, and we're going to go into work with this farm. And what we will do is this is your dashboard. We'll scroll down to import data. And once we click new import, we'll see that we have these three options: download a template from UVM Soil Lab or from another. We are going to import using from a UVM Soil Lab. If you have results from, for example, Dairy 1, you can download a template and copy and paste the information into there. And again, just to reiterate a little bit of what Heather said, make sure that any extract or any soil test you have is using the modified Morgan's extractant. Very, very important. If you've used if you're going to a lab that's using a different extractant, it's not like we can do some algorithm in the back and do some conversion. It doesn't quite work like that. So modified Morgan's very important. But I'm going to switch sharing my screen here for a moment so you can see what the CSV looks like. So Heather showed you earlier what your soil test report looks like, and you might have seen that, you became a little bit familiar with it, but you will also get soil test results in an Excel file. I've already converted mine to a CSV, and I will show you how to convert that, but right now I want to show you in your Excel or in your CSV how you might change the different, how you might accommodate fields that might be sharing a soil test report, or some fields that might have more than one soil test associated with them. So you have a pretty streamlined import.
I'm just like. to see here.
So, and I can help you guys import this afterwards too. We have some very ambitious
She's
people who've
ahead of me.
imported, which has been awesome. So you can see in this file that I've got a couple of, I've got a lot of different columns. I'm not going to go through all of them. And you can see some of them are a little bit out of order. Like I got lab ID, and then I have iron followed by customer sample, which is the name that you might have written in the form, followed by aluminum, and then some other information that like the order number that's not going to be imported. But you may have, for example, a field that was over 20 acres, and you might have two field for soil samples. And what you want to have into GoCrop for your one field is an average of those two. And so in order to do that, one thing that you can do is say, all right, I'm gonna name this field for average. And then right across, you'll take an average of those two by entering into your spreadsheet an equation like average. You'll copy the cells you want to average for that column, and then drag that across to get your average of all of your nutrients and analytics there. And I'm also just got to do that for my iron. It's a little funny that it's not in this order. And now my computer needs a moment to think. See that little blue circle going. And then I'll just also average my lab IDs if it will do that for me. Won't do that. That's okay. I'm just going to copy it just so that GoCrop has every single form filled out. So that's an instance where you might have multiple soil samples that will go to one field. You might have another instance where you might have forgotten to soil sample a field that you need an import for. And so if that's the case, please work with whoever's providing you some assistance to figure out what field you do have a soil sample for that most represents the field that you don't have a soil sample for. And so that would look like having similar soil types and also similar management. And so if that's something that you have going on, I would copy the field that you have the soil sample for into a different row. I'm gonna wait a moment. And then change that field name to the field that you do not have the soil sample for.
You know you're good when your computer can't keep up with you.
Thanks. And then don't forget to save the work you did, because that's really a bummer when you spend this time changing things in your spreadsheet and you forget to save it. One thing you'll notice is that there is a boo-boo here where it did not like the average of my test. And so it just put this other number in. So I'm going to see if I can just copy and paste that into the date here. If you are importing something and there's not a one-for-one recognition that GoCrop sees, it'll let you know and you'll have the opportunity to change it. But I'm trying to set us up for success and getting all our columns looking how GoCrop will accept them. So again, I'm going to save that. And like I said, this is already in a CSV, but you've probably gotten your soil sample results in an Excel file. And to change it to a CSV, what you'll do is you'll go to File, you'll go to Save As, go to the place where you want to save it in a place where you know you can find it, because we're going to need to import it. So make sure you're putting it in your desktop in a folder, and I know you probably, just like me, have a nutrient management plan goodness folder. So if you have one of those, this would be an excellent place to save it. Save this as test 2, and then a save as type. Yours would have said Excel workbook. You're going to want to make sure that you come down to the CSV type file, and notice that there are a couple other CSV Macintosh, CSV MS-DOS. Pretend those don't exist. You just want the straight up CSV. There's also this one, CSV UTF-8. Ignore that. Just regular old CSV. Say this one more time, since I said a bunch of other CSVs. So just save it in CSV. You want plain old, simple CSV. So we'll save that in a location. I'm saving it on my desktop for easy use. I saved it as something I'm going to remember. Click save. All right, now I'm going to come back to GoCrop. And remember, we went into Classic. And just in case you're like, wait, that happened 5 minutes ago. I saw you copy and paste into a spreadsheet. I'm lost. I'm going to show you again how to get back to Classic by first going back to the new GoCrop. All right, so you log in, see your annual plan. We're going back to Classic. I'm going to transport us here. We're going to choose the farm we're going to work with. We have this different display of our dashboard. We're going to scroll down. We're going to click New Import. That was the no-till song. You also come up there, and we're choosing our import, and we're going to say from UVM Soil Lab. Again, if you've used a different lab, let somebody who you're working with know, and they'll be able to adjust it. And if they can't, please feel free to reach out to me. We'll figure it out. So from UVM Soil Lab, I'm going to choose my file. And I'm going to go with the one I just showed you, test2 CSV. Click that, click open. And GoCrop says, hey, great, I see what you have. You have 6 soil tests. Things look good. We're going to click next step. Now what we have here is that on the left side, we have all the field names that we used when we entered or when we submitted our soil sample to the lab. That's the name that we have on the spreadsheet. On the right-hand side, where it says corresponding value, are the field names that we entered into GoCrop. Now you'll see on the left, I've got things like field 1, 2, 3, 4, 5, 6. I don't have a 5, but in a field 4 average. You might have some track and field names. You might also have the names of the field that you call them, just in general. But what you can see is that on the right, none of the fields that I have in GoCrop match what I have on the left. As long as you know what those connections are, you can connect them manually here. If they were to match a little bit more closely, GoCrop would try to make that happen for you. So if on the left I actually had a diamond field, it would probably default to diamond. I'm just going to come through and choose these. And so now what I've done is, scrolling back up here, is that I'm matched all the soil samples I had in my spreadsheet to the ones I have in GoCrop. And then if I scroll down, I can see all these other settings, all our other nutrients, what's in there. And basically what this is showing is that GoCrop's acknowledging that those columns exist. And then it's also saying it's skipping a bunch of columns. So please leave all of these defaults as they are, because what GoCrop is set up to do is to take the nutrients that it needs to be in compliance with state regulations. So remember Heather showed you that soil test report. There's a bunch of other different types of nutrients and other analytes like organic matter on there that may or may not be what GoCrop needs in order to meet state requirements. So basically all you're doing here in the configure section, we've already uploaded or imported our soil test, is matching your soil names in GoCrop to the ones on your spreadsheet. After that, we're going to say preview with these settings. And here we have what GoCrop is saying. You know what? I know we need these 3, sorry about that. these are the things that we need. We need the pH, the organic matter, the cation exchange capacity, aluminum, phosphorus, potassium. You have the option to edit these in here. Again, I would not mess with that if GoCrop's importing that. We have what GoCrop is saying that it has what it needs for 5 of our 6 fields. And we can see that there's an error in one of them. I can say, you know what, I don't have time for this. I'm going to skip it and let's just go with these other 5 and we'll come back and manually enter this 6th one. Or we can choose to see what the problem is and see if we can fix it. So I'm going to click fix. And it's saying that for whatever reason, my cation exchange capacity has this weird number in it. And I'm going to say, look at my soil test and say, oh, okay, I know this is actually 15. I'm going to enter that. And then I'm going to go back to configuration, and which set me back here. I'm going to see if my change in that text box saved. So preview of these settings. It didn't save. I'm going to fix it. Again, I'm going to my soil test, put 15. That's solved that problem. Everything else looks like it's pretty good to go. And I'm going to see if that worked, and I'm going to import it. Keep that. Import in progress. Might take a little while. Got my little gear spinning here. Okay, and it looks like it was able to import 4 of my soil tests. It wasn't able to save that 5th one, so I'd have to go back and get grandma's field all squared away there. So I'm going to close that. And now I'm going to go back to my new GoCrop, my 2025 annual plan. And just to see if this actually went through, I'm going to click soil tests. And now we can see that the 4 that I was able to import actually did come through. So they're all up to date, and then I missed the trapezoid field. And that's something that we could manually enter by clicking on the field, adding the soil test, and then adding those 6 values like we showed last week. So now that we've gone through that, the other pieces that I want to go through today are nutrient sources, nutrient analyses, and also touch a little bit on nutrient balancing. So again, just to reorient us, we're in the planning section. We've gone into our annual plan, and this is our dashboard, and I'm going to go right to nutrient sources. I was playing around a little bit with this today, and so I've already entered a manure analysis and a fertilizer, not analysis, but a nutrient source for manure and also fertilizer. So when you first come to this page, it'll probably look a little bit different. We do have some help text here, so you can add a new source by pressing the button on the right-hand side. We've talked about filters last week. If you have any questions about how to use filters, please connect with me. Otherwise, you can just kind of play with it and figure out how it works on your own. And then, you know, the edit button and some of our other features. If you accidentally put one in, or you have one in and you want to save it for another year, you can amend it from plan. You can always add it back in. But I'm going to show you how to add a new manure source and a new fertilizer source. Either way, once you're at this stage, if you entered one source, you're going to have to go and click new source. At the top, you'll choose if it's manure or fertilizer. It's going to default to manure every single time. We've got help text for a bunch of these different categories. I'm going to open up all those so you can see as we are going through them. And for this manure or nutrient source, manure source, I'm going to choose the name stack. Choose any name that makes sense for you, whether that's pit 1, pit 2, pit out back, stack 1, stack 2, or some other cute name that you might have for your manure source. You can throw that in there. And then GoCrop will ask you if it's imported. So is this coming from another farm? If it's not, if it's a source of manure generated on your farm, you'll click no. Choose these animal types. There's a long drop down here. Choose the one that is most relevant for that source. You might have a combination of different animals going into that pit. Choose the dominant one. Manure type, if it's liquid, slurry, semi-solid, or solid. I think what's really important here is the manure type that you choose, make sure then when you choose it, that the defaults below are for the type of units that it's in match how you think about it. So liquid, we're going to think about that in gallons. And then semi-solid, you might be also thinking about this as a semi-liquid, but really that's going to be thought about in tons. The same as a solid is going to be thought about in tons. We have this question here of estimated annual total. Hopefully you've worked with somebody who used a spreadsheet to estimate the amount of manure generated based off of the number of cows you have, the amount of days of manure gets collected in either your stack or your pit. You'll put that number here. And then you might be someone who is exporting some of your manure. If that is the case, you would put that number here. Typically it is 0. And if you do export or import manure, it's probably really prudent to have an export-import agreement. In fact, I think it's necessary for both parties, at least especially the exporting party, to have that agreement. And then you should also have a nutrient analysis that accompanies that export. So we're going to save this. So now I've got my 2 manure sources. I'm going to add a fertilizer source. I'm going to show you what this source looks like for urea that I've already put it down or entered information for. So this is urea, and you might want to pick like whatever nutrients fertilizer source you're using, you want to use the name that makes the most sense for you. So I might put urea down, but you might put grass top dress, or you might put starter, but make sure it's a fertilizer name that's going to be unique for that source throughout years. For example, if you put grass starter, you might have one grass starter in 2025 and a different formula in 2026. So you might want to put a different name that is a little bit more unique. This is dry. Our other options are liquid, gas. Has choices there. And then we have these questions if it's an organic amendment or contains biosolid. For organic amendment, we basically mean if it's not a synthetic fertilizer, because there are mineralization rates that are associated with organic additions of fertility. Urea is synthetic, so we're not going to touch either of those things. And because I didn't change anything in my fertilizer source form, there's no changes to be saved, so I'm just going to go back. If I typed in, I have notes, then I have, or make another change, then you could, the save button will appear. Now that we have multiple sources, I can cycle through them and see what I have. And at any time, just like when we're in our field list, we can click the list icon to go back. So we can see our list, but we can also add a new fertilizer source or manure source. And I'm going to do that from here. One thing that trips me up all the time is I'm like, all right, I'm ready to name this. But remember that GoCrop's going to default to a manure nutrient source. So before you even start typing the name, make sure it's on, you've chosen the source that you want it to capture. So I'm going to do a fertilizer. So I'm going to choose that from the drop-down menu. And I'm going to choose my fertilizer name, which might be ProGrow. This is, again, it's dry. In this case, I'm going to say it's an organic amendment. And I'm going to save that. But there's another thing I wanted to touch on here for a moment, but it's escaping me. So we might come back to that. So there's how you enter your manure and your fertilizer sources. The next step is to enter our nutrient analyses. And we can click on that by clicking our from our steps on the left, or we can click move on to next step in the lower right. And I'm going to go ahead and do that. Oh, apparently I've double clicked it. So we're going to try this again. There we go. So this is a little confusing, right? Because now it looks like we have the exact same page that we just came from. Nutrient sources, says nutrient sources up top, nutrient analyses, same list, but nutrient analyses at the top. And also now we have on the right, instead of complete, not complete, because we're trying to capture analyses, it says up to date or due for test. So we have a bunch that are due for tests. Particularly, I just want to give a shout out to our manure analyses is that really you need to have one of those every single year to stay in compliance. And so I've already entered one for my pit. So it says up to date. So let's enter one for my manure stack. I click on that and I'm going to add my manure test. It tells me, you know, that I'm in my stack as my manure source. It defaults to today as my sample date, but I have a manure sample from a few months ago, or in the case that you weren't able to get a manure sample for this nutrient management plan, in the interim, in the in-between time of now and when you do get that manure sample, you can use book values. And if you do use book values, you can choose whatever date makes sense for you in the last 12 months. And then you can use the Vermont field nutrient recommendations for field crops in Vermont. And there's a handy table on page 20 that has your book values. And I'm gonna, for my lab, I'm gonna put book values here as a reminder that this is something that I need to update. Few notes there. And then on page 20 in the nutrient recommendations for Vermont field crops, I'm gonna look at table 15. If I'm have a source from dairy cows, and if not, a different animal type that's going into this nutrient source, I'll use table 16. And I'm going to put this as my solid values here because it's a stack. One of the things that you'll notice on your manure sample result analyses and also in table 15, and I know Heather mentioned this too, is that you'll have a total nitrogen that is the sum of your ammonium and organic nitrogen. Don't put your total nitrogen in, just put what Go Crop is asking for, which is your inorganic and your organic nitrogen. So in this example, it's 1.4 and 10.9. And do 0.1 here and 10 for potassium. If there is another nutrient you want to track, you can by adding another. When you're first making your plan, I would really recommend just keeping it to these 4, and especially please do not add another into your total nitrogen. Even if you're like, oh, I want to keep that in Go Crop, what Go Crop ends up doing then is double counting your nitrogen sources. So just leave it as your inorganic and organic nitrogen. Do not add another row to capture your total nitrogen, or for that matter, don't put your drop down and change it to total nitrogen. I know that I'm excessively talking about this, but we've seen this come up in some other plants and it causes a lot of hiccups when we're in the balance. So just to reiterate, for the sake of repetition here, please keep your nutrient analysis that you're entering into Go Crop as the ones that it's asking you for the default values: inorganic nitrogen, organic nitrogen, available phosphate, and soluble potash. This is another good check to make sure that you're entering an analysis for the source that you need to by looking at the units. So this is pounds per wet ton. It belongs to my stack. And this kind of makes sense to me. Just another note on this too, when you are looking at your manure analysis report, it'll probably give you your nutrient analyses in like 3 different columns. And one of them would be pounds per wet ton. And also, I think, pounds per 1,000 gallons. So when you're entering this information in, make sure you're using the column with the correct units. I'm gonna save that. And now this is a new feature I'm really excited to use. I could go back to my list and choose the next nutrient source I want to enter an analysis for, but instead I'm going to use this handy arrow. So excited about this. I'm going to ProGrow and I'm going to enter my next analysis in. To do that, I'll add fertilizer analysis, right? Back here we were in stack, it told me manure analysis. Here I'm at fertilizer analysis, all in the nutrient analysis step. And same thing, I'm going to enter the analysis for ProGrow, and this is based off of a percent. You can probably get this from the fertilizer tag. I'm going to put some random numbers in here right now. So if you have ProGrow and you see me putting this in there and you're like, that's not it at all, I'm sorry, I'm just putting some numbers in here. But remember, ProGrow was an organic fertilizer source. It wasn't synthetic. And so because it's an organic fertilizer source, the nitrogen in it might take a while to become plant available. Remember Heather showed you some of those different tables showing availability from different sources. And so when using organic fertilizer source, we want Go Crop to be able to capture that and attribute that as well as we can based off of some estimates. So in general, from an organic source, we estimate a 30% nitrogen mineralization rate, 30% plant available nitrogen amount. You can override this if that is not accurate for the source that you are using. Save this. And now that we've entered our fertilizer analyses, it's already changed to up to date. Versus when we go to urea and it says it's due for a test, it's nice to have that little bit of a check. For urea, you're going to put in, or whatever other synthetic fertilizer you have, you'll put in your nutrients there. If you're using something that has something other than nitrogen, phosphorus, and potassium, again, just like you can for your other sources, you can add another and say maybe this one has sulfur in it or boron, and you want to capture that, you can add that in here again as a percent or wet ton pounds per 1,000 gallons. Keep that unit uniform, keep it the same as all the others are. So for this case, because it's synthetic fertilizer and I've looked at the tag, I know that it would be in percent. But also in this case, because it's just urea, sulfur is not a part of it. So I'm going to delete that row by pressing the red X. And I'm going to save this. And then we're going to move on to our next step, but just for a moment, I'm going to go back to our list and we can see that all of them are up to date, and that's pretty satisfying. So we've done some good work there, and now we'll move on to equipment. Because we're at the equipment step the first time, Go Crop's like, hey, I know that you want to enter equipment here. Why else would you come here? So it puts the form for us immediately. And we're going to enter our spreader information here. You might have other equipment like planters and tillage equipment that you have on site that you use. But right now for Go Crop right now, all we're asking for is spreader information. And really that's all that you can put in there. Like I just clicked this little drop down. Spreader's your only option. You can't do anything else. I'm going to open up all this help text so you can see it as we go through. And we're going to name our spreaders here. So maybe we'll have a whole spreader and we'll tell it Go Crop if it's a liquid, semi-solid, or solid. And really that's just telling Go Crop, do you think about this in gallons or do you think about it in tons? And then it's going to ask us some of that calibration question information. So how big is the tank? And for this, you might want to put how much you often put into it. So maybe you are filling it up the full 6,000. Maybe you know for whatever reason you're putting a little bit less in. This is why it's so important to calibrate your equipment to know what's actually going in. And then because I did calibrate my equipment to be in compliance, I'm going to click yes. If you do say no here and we're reviewing your plan, it's not in compliance. So, take that for what it's worth, but in order for your plan to be in compliance, your equipment needs to be calibrated. And then we have this question if it's custom applied or not. And if you say no, it's because you are doing it. What's really nice and about this is that the information you feed into Go Crop here goes into a report that will show you how many loads you need to meet the planned rate of application on a particular field. And so that's partially why it's really important to have calibrated equipment so that report is accurate and can help you throughout the season. So I'm going to save this. And now we have some of our help text here. If we want to add new equipment, which we do, because remember, we also have our stack. And so tabs here, this is a solid and can hold 5 tons. It's calibrated and it is not custom applied. If you do work solely with a custom applicator, it is also important to put all their equipment in here too, because again, that'll be helpful to generate those reports so they know how many loads go to a field when based off of the planned application rate. I'm going to save this. So now we've done your nutrient sources, your nutrient analyses, your equipment. At this point, you've also put in your field information, which is really exciting. And I wanted to pause here for a moment because I wanted to show you that I have all my required information filled out here. So everything says complete in the form. But when I go to land information, it says my trapezoid is incomplete. And part of the reason for that is back in my fields, I didn't map it out, right? I have my orange fields from other fields that I have mapped out, but I don't have my red trapezoid field mapped out here. And that means when I went to land info here, it didn't have anything to pull from. So I can pretty quickly enter, I can either map that out or I can choose a dominant soil type, but I just wanted to show you that might be something that happens. I don't have any nutrient analyses or soil tests for my trapezoid. Remember that's an import through. So if I wanted to or needed to, I could add that information here by adding the soil test. Otherwise, we can see that my square has a bunch of imported, rectangle imported, my grandma's field imported a couple times too. We've done our risk management, go to our list here for that, everything's complete. We've done our crop rotations, we've done our crops. One thing that I would say here is that at some point you'll want to go back through and make sure that whatever crop you marked as the crop for that field. So for example, in my square, I've marked hay. When I go to my crops for my square field, I want to make sure that I've chosen hay to make sure that those end up matching. But now I'm kind of giving like Go Crop like a analogy of a game. And to me, like we've gone through all these steps, all these different levels, and like nutrient balancing is like fighting the big bad boss. So we got to like level up, and we did all this information to get our like health points up, to get everything we need to do our nutrient balancing in the previous steps, the previous levels. And now this is the place where it all comes together. So when we hit our nutrient balancing, again, in our list phase, we can see all our field lists. We can see I've already started one. It says in progress, and all the others I haven't started say not started. So let's check out the rectangle field. And I'm going to open up my screen a little bit more so I can just concentrate on the balance of plant nutrients step right here by collapsing my left menu, my main menu, and also my side step menu. Because I think it's really helpful to look at this page in particular with as big a screen as you possibly can. So on the left, you'll see balance of plant nutrients. This is coming soon. So this will be a table where you'll see the recommendations, past applications or past credits, and then planned applications as well. So just for today, what we'll focus on are credits from 2024, planned manure application and planned fertilizer application. What you'll also notice is that I'm in my rectangle field, right? And if I come back to crops, my rectangle field says, hey, because you entered in your soil test information and we can see your soil, like your other field information, we can create recommendations for you. But in nutrient balancing for the rectangle field, collapse that, it says recommendations are blank. Don't worry about that right now. So remember, Go Crop's still a little bit in transition. There's still more to come. What this is basically is happening here is that their recommendations are showing up in crops, but it hasn't been connected to your nutrient balancing section. So don't fret about this. Just ignore that your recommendations say blank, because that'll come next week all on its own. But what I do want to show a little bit here is from credits for 2024. I don't think at this point we're necessarily asking you to account for manure applications, but if you are rotating from a hay crop to an annual crop like corn, there is a plow down credit, and that's where you're going to enter that here. So if you had hay last year and you're going into corn in 2025, what we're going to do is account for those credits from the crops. Remember, Heather was telling us a little bit about that. So for credits from crops, you'll choose which crop makes the most sense for you based off of what was grown. So if you've got a really strong alfalfa field and you're plowing that in or no-tilling in to that this year into some corn, you're going to choose that. Or if it was just straight up hay, but really well producing, 4 tons or more, you know, high yield there. Or if it was a so-so field or for whatever reason production wasn't very low, you'll choose the grass low yield. So choose the type of perennial forage that makes the most sense for your system. And all this does is it credits you nitrogen. It doesn't credit any phosphorus or potassium. It just credits the amount of nitrogen. And these are based off of lookup values that you can take a look at what those should be quantified as in your field crops recommendations guidebook. Save this here. If we actually had our nutrient balance table up, it would show the recommendations on the left, and then it would start crediting that in another row and start balancing that for us. But you'll see more of that next week. So the other two things I want to show are planned manure applications and planned fertilizer applications. And to add those, we have these two sections. So I'm going to click the add button here. That'll pop up this form. And then just for today, we're going to concentrate on the top half of this form. Because the bottom half isn't quite set up yet. So we'll choose our mid, when you first plan on applying your first planned application of manure, you'll choose the source and it'll default for you. If it's a pit or a stack, you get to choose, but it screens out any of those fertilizer sources. And then you'll choose the rate. And again, based off of the source, GoCrop knows if it's in gallons or tons. At this point, we'll see if we can save this. And we can. And I'm going to open that back up because I just want to show you, right, that we do have there are different choices for incorporation methods, and those do impact not only the amount of nitrogen available, but also your phosphorus index. But this part of the form is not hooked up yet. It won't save if you choose a time to incorporation. So for this time, for this class, just ignore the incorporation method and we'll come back to that later. If you want to apply, plan for another manure application, you'll have to go down here to the more and click add. Up at the top, you'll choose either manure or fertilizer, and then you'll fill out the same form. I'm just putting some dates in here. Oops. And we'll save this. And GoCrop will start stacking up the different types of, or the different amounts of manure applications you have. Same thing with a fertilizer application. You'll click the add button. Or if you're not applying any fertilizer and you want to make a note of that, you'll say none this year. If you change your mind, you can always come back and say, you know, I'm actually not going to skip it on this field. I'm going to apply the fertilizer application. Do that, click add, choose your plan date. And again, it's a plan, so there's some flexibility. GoCrop here isn't asking for like April 15th at 2 p.m. It's like mid-April, whatever mid-April means to you. You choose a month also that's most applicable. Choose your fertilizer type, the rate, the application type. Whichever is most applicable, how you think about it. I guess in mid-August, it's not gonna, or mid-April could be a starter. And again, we'll leave the incorporation method blank because it's not saving that at this time. Well, but now it's telling me it can't be blank, so I'm gonna put it in. We click our fertilizer application. It did save all my information, so the fertilizer application will keep in your incorporation method. But at this point, it doesn't look like the manure application is. We'll just double check that in case something happened differently in the last couple of hours. I think I did that for this one, and yeah, it will keep my incorporation method, but not my time to incorporation.
Incomplete because something's not. Okay.
I saw that earlier, but it could be because So Ivy was just asking me, I was whispering very quietly, that why does credits from 2024 say incomplete? It may be because we don't have any records or plans from 2024 for Go Crop to draw back on or draw from. But if you've entered in anything from 2024 and it still says incomplete, don't fret about that. Again, we're in a transition phase, so some of these things will kind of come out in the next couple of weeks and will change according to updated code, not to the data you entered. So it'll just make things a little bit more seamless. If you have come to a field and you're not going to put any nutrients on it at all, and you want to tell Go Crop that, you can be like, you know what, I'm done balancing. So there's this check up in the right-hand corner where you can be like, you know what, I'm all done doing this. You can always come back and say, actually, I do want to continue balancing. And part of what checking this button does is it gives us our satisfactory list points over here in our dashboard, or sorry, not in our, which is not there. Go back to planning. It'll give us a green check mark if we say that we are done balancing on all of our fields in the nutrient balancing row in our plan checklist. So you can see that we've entered nutrient sources, nutrient analyses, and equipment, and Go Crop says, you've entered something there, we're done, which may or may not be true, right? Because again, Go Crop checks for completeness of something, but not necessarily accuracy. So it doesn't know if you've really entered in all your nutrient sources or not. Only you know that and can check that by clicking the row that you want to look at and verifying that you've actually accounted for everything. So I think I've covered what I can cover today, unless there are any questions. I'm going to take the resounding silence as no question or everybody's sleeping. Not sure.
Go with the no question.
That's nice. That's nice. I appreciate that.